All right, hello everyone. Welcome to oh shit. But as you can see here, today we are learning our topic today of subspaces. So, subspaces. Okay, yeah, so a subspace is pretty much known as a space that is within a space. So, if you have your space that contains this has all your vectors, right? All your known functions, all your known everything, right? This is called A, right? There's everything in A, right? Now, hey, stop it. Get it. This right here, if you had a space here, another space called B, this is a subspace because everything in B is in A. Okay, so let's just take a look at some of the problems that were asked. So all we're doing for this question is we're just answering yes or no. S, our subspace, is alrighty here. So when there's two things when it comes to, or a couple things when it comes to checking for if it's a subspace. And the first thing you want to do is check if the zero vector is in it. So the zero vector in R3 is just simply, I apologize for the cluttered board, but I will clear it up in a second. But this is the zero vector right there. 0, 0, 0. X being 0, y being 0, z being 0. So does that satisfy this equation? Well, let's see. Does 0 equal 0? That's true. Does 0 equal 0 over there? That is also true. So that satisfies this equation. So that satisfies this subspace. That doesn't mean it's a subspace. We also have to check if it's closed under what is it? We have to check if the subspace is closed under the operations of addition and scalar multiplication in V. So now that you've seen the set notation for that, if we want to put it up later, we can. But also we can erase all this so we have more space. Let's see. Okay. When you're checking the subspace, right? What you want to do is, if you want to check it under closed addition equals 3x, y equals 2x. All that means is if you take any vector from here and you add it with any vector from the other one, if you add them together, are they still in R3? So let's see. So if you took 2x plus 3x, so let's see, that's a equals 5x. So this is anything that you just added to 2x plus 3x, that right there. So all that is, if you just say anything equals this right here, this is indeed just another just x. So it's the same thing. And if you want to say either one of these, if you multiplied this by 5, or if you multiplied this by 7, or if you multiplied it by anything, this would still just be an x. So it'd be the same thing. So in that case, this is a subspace. So for this question, the way we would answer it is we would say the set notation for this subspace is x, y, all the vectors of x, y, and z in R3 such that z equals 3x and y equals 2x. Okay, and then you would also say yes. Okay, next question. All right, so now this time our vector space is all matrices. That's just saying it with the real numbers, but all M2, which is all sets of 2 by 2 matrices and with determinant 1. So what does that mean? With determinant 1. So if you said, so what your sets are gonna look like, okay, is they're just gonna look like, let me see what it looks like in set notation. Okay, so you're gonna say your matrix A belongs to all M2. So all matrices in M2 with determinant 1. Okay. Let's check the zero vector. The zero vector of the 2x2 matrices look like this because it's just, that's what the zero vector is of the zero vector of a 3x3 matrix, you ask? That right there. A 4x4, yeah? Okay, yeah, no, we don't need to do that. But it's just all zeros. So the determinant 1, if the determinant is 1, then that must mean... So if we know the definition of what a trace is, and we know what the definition of determinants, not definition per se, but just like, I guess traits about them. The one trait about a determinant you should know is that the product of a determinant, the product of a oh my gosh, no. The product of a diagonal matrix is a determinant. Is the determinant. I'm not even gonna write it out, but this is something you should know, and you should listen to right here. The product of the diagonal of the matrix is the determinant. So if the determinant is 1, then that means you're gonna need 1 times 1. Anything you're gonna need something like that, right? And if that's the case, already, this can't be 0, 0, 0, 0. You can't have that because this isn't in the party circle of having a determinant of 1. So all matrices with determinant of 1 is not a subspace of this because it doesn't contain the zero vector. Alright, so this is going to be the last problem that we're going to do for today. Taking a look at this, our vector space is P2, which is all polynomial functions of degree 2. So that's all these things right here. Ax squared plus bx plus c. Doesn't even, you know the deal with those. So yeah, so this is our subspace that we're given right here. And taking a look at this, what does this mean? This is all functions. We could even put this if we want, f of x and f of x if you wanted. But so all functions that belong to P2 such that it satisfies the f of x equals ax plus 1 or ax squared plus 1. So first thing we're going to do is f of x equals 0. Is this true? Let's take a look. Well, when x equals 0, does that equal 0? No, so no, this is not true. That's it for this question, and that's going to be it for this video. Thank you guys so much for watching. If you guys like these types of videos, go ahead. Comment down below. Go ahead, let me know what we should do. I'm going to do more linear algebra coming soon. But yeah, so here's a little... They're just chilling right now, but... Go ahead, join the community, make sure you get your homework done, and always remember, never forget, the turtle won the race. Let's go.